Hello, Doctor. I am Irvin's David. I will be representing our group for the mini group project presentation of cloud computing. So, we will move on to the project scenario and current challenges. The context of this project is that University ABC operates an internal e-learning platform for quizzes, forums, and assessments. The current infrastructure for the university is an on-premise hosted in the campus data center. The problem is the university is facing slow loading times, delays during peak usage hours, and a single point of failure due to service interruptions of hardware limitations. The objective of this project is to migrate to a cloud solutions to fix latency, scalability, and availability of the university's platform. The problem identification. So there are three problems within the university system, which are server resource saturation caused by compute bottlenecks through fixed CPU RAM capacity. Next is storage input-output limitations, the throughput limitations leading to high latency, and then the lack of availability due to single point of failure or SPOF risks causing interruptions. Next is the analysis of causes. Cause number one is compute bottleneck. The current monolithic architecture hits a vertical scaling limit, and the concurrent requests exceed processing threads, causing request queuing. And then next is the storage latency. A high I/O weight due to random read-write operations of videos and slides. This is likely with the use of hard drives or standard rate limits of input-output operations per second, saturating the storage controllers. And then finally, it is the SPOF, the single point of failure, because there's no clustered redundancy, hardware failure, or maintenance forces the entire service offline. So, what is our cloud strategy? The deployment model is used, which is the hybrid cloud. This combines an on premise infrastructure with a public cloud provider. Why hybrid? Because of cloud bursting. This keeps baseline traffic local because it bursts to the public cloud only when the CPU hits around 80% usage. And then data sovereignty. The student PI and grades remain on local firewall servers to meet data residency laws. And then finally, the cost optimization, which leverages existing hardware while using a pay as you go model only for peak demand. What is our service model? The service model used is IaaS, which is infrastructure as a service. This combines an on premise infrastructure with a public cloud provider. The rationale is a lift and shift. This allows the migration of the legacy application of the university with minimal code changes. And then the operational control is unlike PaaS. IaaS grants full OS level access. And then the IT staff can install specific security patches and custom middleware required by the university's specific system. The technical components of this proposed system is this. The compute component will use an elastic cloud server or ECS, which solves the saturation by providing resizable virtual machines that scale instantly via auto-scaling to handle peak loads. The next component will be the network. The service is Elastic Load Balance or ELB. This solves the SPOF problem by distributing traffic across multiple healthy instances and reroutes requests if a server fails. And then the storage. The service used is Object Storage Service or OBS. This solves the input-output bottleneck by offloading large static files, such as videos or PDFs, to a dedicated layer, freeing up the main server. The database component will use an elastic volume service or EVS, which solves the system lag by using a high input-output SSD or solid state drive to ensure rapid read-write speeds for database transactions during quizzes. And then the resilient component is the cloud backup and recovery or CBR, which ensures continuity by creating automated snapshots to protect the university from data loss or corruption. And this is the architecture diagram. The entry point, as we can see here, connects the user via the internet or campus network through a firewall. And then the traffic distribution is handled by the ELB or elastic load balancer, which routes the traffic to healthy ECS instances. In this case, our virtual machines. And then the scalability, there's an auto scaling group here, which adjusts the ECS counts dynamically. And then the data decoupling, the static files are stored in the OBS, and then the structured data are stored in the RDS. What are the expected benefits of using a hybrid model? Well, number one, performance optimizations. The OBS offloads huge file downloads to prevent clogging the app server, and the ELB routes traffic to the least busy server to ensure quick response times. And the cost efficiency, the OpEx over CapEx eliminates investment in depreciating hardware. With reduced labor by the cloud provider manages power, cooling, and allowing the IT staff to focus on software. The scalability of it is that it automatically creates ECS instances when the CPU thresholds are breached through autoscaling. And this guarantees capacity increases linearly with demand, such as during exams. And then the risk evaluation. There are three categories, one of which are data security. The challenge is storing data on shared infrastructure raises breach concerns, but the mitigation strategy will be to implement IAM policies and enable encryption. The next risk category is connectivity. Reliance on public internet can cause latency between private or public clouds. Well, to mitigate this, we can implement a private line to bypass the public internet by directly connecting to it. And then the risk category of cost management. There will be some misconfigured autoscaling can trigger runaway scaling and budget overruns. Well, we can mitigate this by configuring the maximum instance limits and set automated budget alerts. So the conclusion is the legacy infrastructure is the root cause of latency and downtime. So moving to a hybrid cloud architecture eliminates SPOF. The final verdict is the proposed solution for the university ensures a 99.9% availability, infinite scalability for exams, and optimized costs for the university. That is all from us. Thank you.